Good morning. I hope everybody is safe out there. Before the COVID-19 virus, we were planning on doing these wonderful courses in Portugal where people would come here for anywhere from a 1 day to 5 days, and we would provide some courses on developing forecasting and policy analysis systems. And the idea was that this would help people make the transition from academia into a professional setting. In other words, working at maybe a policymaking institution or maybe in the financial industry or so on. Now, given that we are all locked in, we decided to basically go ahead and create Zoom videos. Now, so this presentation that I'm going to give to you today is an example of one aspect of a state-of-the-art forecasting and policy analysis system. Obviously, if you're forecasting, you have to understand what you think the state of the economy is. And so this is all going to be about monitoring the China PMI using satellite data, okay? Now we want to emphasize that instead of like building a complicated comprehensive model of the state of the economy, we think the state of the art is to actually be much more flexible and to look at everything that's relevant. And of course, now what's relevant during the lockdown is to figure out measures of activity that would give us an idea of where the economy actually is. So it's going to turn out these satellite data look to be much more informative than lag time series for figuring out where the Chinese economy is and where it has been. Okay, so the presentation is going to be organized along these lines. So we're first going to talk about the data and how we're developing the data. And aggregates of the data in particular. And then once the data has been developed, we are then going to do some data analysis. So we're going to do some graphs and some regressions showing that these data have good predictive content for understanding the state of the economy. And then I'll talk a little bit about future work. So SAR data. So SAR stands for Synthetic Aperture Radar. This is a program that was developed in Europe. It was launched in 2014, and it's coordinated and managed by the European Commission in partnership with the European Space Agency, the EU member states, and EU agencies. Now, the objective of this project is to achieve global, continuous, autonomous, high-quality, wide-range Earth observation capacity so that people like us can use it for the types of applications that we're going to be using it for. Now, what's special about SAR is that it uses radar images and they can see through clouds. So we're not going to have the distortion with other types of satellite technology where clouds can be a problem. Now, how does this work? So there's a company called SpaceKnow, and it takes snapshots after it identifies these industrial sites So it takes snapshots of these sites on a 6 to 12 day frequency. Okay, and these sites could be mines, refineries, container ports, manufacturing parking lots, and so on. And they do it in China and as well as other countries and so on. And so then they apply an algorithm to these pictures, which tracks the magnitude of changes from image to image. Okay. Now, to be able to understand this, my favorite pictures are looking at things like fracking operations in Texas, in particular, looking at the El Dorado mine, which started construction in 2017, and the Best mine, which started construction in August 2017. So this is a good example of what it looks like when you look at these pictures and how they evolve over time. So in developing a fracking operation, you can see that these people don't mess around. They begin construction on the mine, the El Dorado mine in June of 2017, and the Best mine in August of 2017. And we can see the development of the mines over that period. By November 2017, they already have roads connecting the mines. And then they start production in January 2018 at the El Dorado mine. And at the Best mine, they start production in April 2018. And then by July 2018, they actually brought electricity in. So you can see that this whole operation of fracking in the United States is an incredibly quick and dynamic process. So in the case of China, we're going to start off with 1,304 industrial sites. So there's going to be a lot of noise in these data, okay? And so this is the main problem that we've had to deal with, about how to think about aggregating these kinds of data after they've been constructed. And so what we're going to do is we're going to take those sites that have SAR time series that are correlated with the PMI. Before we do that, we're going to normalize each industrial site SAR value based on quintiles. So we're going to divide up activity in each one of these sites into either very low, that would be the first quintile, low, which will be the second quintile, normal, which will be the third, high, or being the fourth, and very high, okay? And this is sort of similar to the way that the PMI is constructed, in the sense that it's an indicator where they ask people about things, and usually it's 0, 50, or 100. And so what we're doing is trying to use a similar kind of methodology for measuring activity, but instead of asking people questions about activity, we're going to be looking at the pictures to measure activity in a similar way. So how does it work? So we're going to take, after we construct these quintiles, we're going to take simple unweighted averages of them. To obtain the index, we're going to check the correlation of each of the 1,304 sites with the PMI, and we're going to exclude those sites that have correlations below a critical threshold correlation. And so the critical threshold correlation that we're going to use is 0.3, 0.25, and 0.1. And so when we exclude sites on this basis, we're going to end up with 3 measures of this SAR index. We're going to have SAR 129, which includes 129 sites where the correlation with the PMI is greater than 0.3. And then we're also going to have SAR 191 and 575, where we have a looser constraint on how correlated these sites are with the PMI. So we could also, after we construct the index, we can also go back and use all of the sites to look at the distribution of activity. So for example, we can ask in the complete sample, what is the percentage of industrial sites which are registering very low activity? Okay, so we can look at it that way. So these are just looking at the data that way. And so what you see here in the blue line is that during the lockdown of Hubei province, between January 23rd and April 8th, we saw very large increases in the distribution where there was very low activity. So this, of course, reflects the lockdown. And in April, we observed also a lot of sites with very low activity, but this is not related to the lockdown, but it's related to the fact that the lockdown outside of China then started. And so there was obviously concerns about activity in other countries and whether or not they should be producing a lot of output that they couldn't sell because there was no demand for it. Okay, so this is moving on to the analysis of the data. So before we begin anything, we start with some graphs. And so this is just looking at the manufacturing PMI. I emphasize that this is the measure from the official institutions in China. And the three indices that we've created based on these SAR variables. And you can see that they're correlated, particularly during the period where there was the lockdown in China in February. This is looking at the data in logs. Okay, so the correlation looks much stronger when you graph it in logs. And so, not surprisingly, we're going to be using log specifications when we estimate our regressions. So the regressions that we're going to use are, first, to transform the data, both the PMI and the SAR values, by multiplying 100 times the natural logarithm of the series. And that's going to give us these variables called LPMI and LSAR. And so you can see there's going to be three regressions. One is going to include the 129 SAR, the 191 SAR, and the 575 SAR. And then we're going to ask which one of these regressions actually works better in terms of monitoring the state of the PMI. So the idea is that we can monitor these SAR variables before we can actually get released data for the PMI. So the SAR data are going to be monitored every week, and the PMI for China is actually published at the end of the month. So as we go through the month, we should be developing a better estimate of economic activity in China until the final data are released. So these are some data that are based on, let me emphasize that this is a very small sample of observations that we're using. The data only started at the beginning of 2017. So this is a regression that goes from February 2017 to March of 2020. And this is a specification that includes the contemporaneous SAR 129 variable and the lag. And you can see that there's a pretty significant relationship. So the contemporaneous coefficient is 0.08, and it has a t-statistic of over 20. And there's also a lag, a small lag of minus 0.008. It has a more marginal significance, but it is significant at the 5% level, okay? And we can see that the standard error, the regression, is about 1.7. So you can see that it fits the downward movement in activity in the PMI during the lockdown quite well, as well as the subsequent rebound afterwards in the PMI. Now this is very, very important because when you think about the PMI, when there's a lockdown, we should be observing a low PMI. And then if the PMI goes back to 50, that's not an indication that things are great, because it means that the level of activity hasn't gone back to where it previously was. It's basically saying that it's been stuck at where it actually declined to. So there seem to be some problems when you look at people forecasting the PMI for China, because many people were forecasting that the March PMI was going to be a lot weaker than what it actually turned out to be, okay? So they were expecting further deterioration in the Chinese economy, whereas it's best to think of it as a big decline that basically just sort of stayed bad through March. Okay. So this is just looking at the results for 191, okay? Also a significant relationship between the SAR variable and the PMI. It doesn't quite fit as well as the earlier one. And then this is looking at a much broader measure that includes 575 sites. Again, it's very significant, but doesn't fit the data quite as well as the first one. So the conclusions at this point are SAR 129 has the best fit in terms of the R squared, has a pretty big R squared, actually explains 92% of the variation. It has the smallest standard error of 1.73, and it has a small value of the residual actually in February 2020 when there was this big collapse in the PMI. So the forecast error was only about 1%. So this is basically just showing the small errors during the lockdown and so on. So now we want to move to forecasting April. I need to emphasize again that this was done based on data for the first 2 weeks of April, and we're going to update it to include an additional week just before the PMI is released at the end of April. But this shows you the data. So you can see the PMI in December, January was about 50. It then fell largely to about 36 in February. And then it recovered to about 50, actually 52 in March. So the question is, what are the SAR data? What do they tell us about the April number? So if you look at the SAR, the different SAR measures, you can see that they all decline a lot in February. The SAR 129 declines the most. It falls all the way from 39 to 0.8. and they'll recover to about 42. On the right-hand side, the last column reports the historical mean back to the early 2017, just so you can put these numbers into an historical perspective. So anyway, when we take these estimated regressions, we can then compute what the midpoint of the forecast would be, and they're suggesting that based on the SAR data, that the PMI will be somewhere between 49, okay, if we look at the alternative models, and if you believe in SAR 129, and 46 if you believe in SAR 575. And we also provide, obviously, a range of confidence bands and so on, okay? So let's compare this with some other forecasters. This is looking at the forecasts of investment.com. And as you can see, over the historical sample before the lockdown, the red line is the forecast and the yellow is the actual. You can see that the model was fitting the data fairly well, but also making predictable errors. So we don't actually know the model that is used to produce these forecasts. But from the looks of it, it might actually be an autoregressive time series model. And why do I say that? Because when you look at the pattern of the errors, so you can see that when the actual PMI is strong, then the forecast is strong. And then of course, when the PMI then falls, it makes a forecast error. And so you can see that it's sort of making sort of predictable errors, like the forecasts are being driven by lags of the past PMIs. And that's sort of consistent with how it forecasts during the lockdown. So you can see that it completely misses the big crash in the PMI and forecasts like a very gradual downward shift in response to this thing. So that's an example of other forecasters. Now, what we can do is do more formal analysis comparing this forecasting equation based on the SAR and these forecasts that are constructed from other methods, like what is in investment.com. So the very first thing to do, since they probably used a larger sample in investment.com in their forecasts, is just to estimate a simple regression where we forecast the PMI with their forecasts of the PMI, and then we simply just augment that regression with the SAR data. So this question then is asking specifically, are we improving things? Are we improving the forecasts relative to alternative forecasting methods like what's published on forecasting.com? But first, we check the regression and ask, well, how well did our PMI data, how well is it forecast with their forecasts of the PMI? So we just estimate a regression in logs where we take our PMI, we regress it on a constant, and this forecast PMI, which we call PMIF, and we see that we get a coefficient of about 1. It's highly significant. We get a standard error of about 1. Now, this is estimated up until January of 2020 before we see this big crash. Now, what we would expect with those kinds of time series models that are used to forecast things like the PMI is that when a big event comes along, like the lockdown in China, that the parameters of the model effectively fall apart. And that's what we sort of see here, okay, in the sense that the parameter with 2 new observations on the PMI forecast jumps from around 1 to about 1.2, and you can see that there's a gigantic error in the equation. It can explain the massive decline in the PMI, nor can explain the massive rebound in the PMI. I think that was pretty obvious just from the graphs that I showed you earlier. So this is just some formal statistical evidence. So the next thing we can do is to ask, well, let's take an augmented model that has both the PMI forecast from investment.com and put it up against the SAR variable. So this is an example. So now the coefficient on the PMI forecast variable, drops from around 1 to 0. Actually, it's minus 0.04. Becomes insignificant, and of course, the SAR variable does, much better. And you can see that obviously graphically by looking at the actual and fitted value of the equation, as well as what the error terms look like. Okay, so it looks like these SAR variables have some interesting information in them. So what's some potential future work? Well, first of all, we need to provide a lot more sensitivity analysis and apply this to other countries and so on, as well as specific markets like the oil market and so on, where it's naturally suited to do. And so that's part of the aspect of this research agenda. And the second thing is develop training material more generally so that economists can learn about policy modeling. And so if you're interested in learning about policy modeling and how it's different from academic style modeling, you can email us at laxtoneconomics.com to sign up for alerts about future courses and training materials. So just let me emphasize, be safe, and I hope to see you in Portugal at the Better Policy Project, maybe attending one of these courses. These are just some nice pictures of Portugal that you're missing out on because of the COVID-19 problem. Thanks for your attention. Again, this is just a slide telling you that if you're interested in the courses, you can look at www.thebetterpolicyproject.org. It will be listing the courses, and in the very short run, those courses will be free. At least the introduction to the courses will be free. You'll be able to listen to them through Zoom videos, much like you've been listening to this one today. And if you want any further information, you can email us at laxtoneconomics@gmail.com. In addition, if you're interested in modeling resources for policy modeling, you can check out my website, douglaslaxton.org. For the data, the specific data, these satellite SAR data and other data that are created from the satellites, you can contact Jared Laxton at laxton@spaceno.com. Anyway, Thank you very much for your attention.